Welcome back to part 2 on rational functions. We're going to look at horizontal and vertical asymptotes in this video, but I want to define some things first. We can have vertical asymptotes that are either positive or negative, so they could exist vertically anywhere along the x-axis. If we have an x value that we are approaching, and it is a vertical asymptote, we'll call this A. We could either approach this vertical asymptote x equals A from the left or from the right. And we could have several different scenarios for this happening, so I'm just going to go ahead and draw the vertical asymptotes in all of the different scenarios first. This takes a minute. Okay, so here are all my vertical asymptotes. Notice they're all in the same place, but they could be anywhere along the x-axis. That's why it says plus or minus A. So now we're going to say as x approaches A from the left. Notice that I have this little negative symbol that kind of looks like an exponent. That means from the left. And if you wanted to have x approach A from the right, you would say as x approaches A from the right with a little exponent that is a plus sign. This means from the right. So now that we've defined the notation, we can use this consistently throughout the rest of the examples, and hopefully you will understand what they mean. So as x approaches A from the left, we could either have the function approaching positive or negative infinity. So we will have two solutions for this. So I'm going to draw this again. As x approaches A from the left, we could have f of x approaching positive infinity, or we could have f of x approaching negative infinity. So let's just draw what that would look like. As x approaches A from the left, so coming in on the left side toward the vertical asymptote, if the function approaches positive infinity, it hugs the vertical asymptote to positive infinity. It moves upwards, not downwards. Similarly, if the function approaches negative infinity as x approaches A from the left, the function would do something like this, where it moves downward as it gets closer and closer to A on the left side of the vertical asymptote. Now let's look at what would happen if f of x approaches negative infinity. But our x values are A, but on the right side. So we are approaching the vertical asymptote from the right, and we are heading toward negative infinity. It would look something like this. Now, let's look at one last possibility. As x approaches A from the right, f of x approaches positive infinity. That would be the last possible scenario. So this would be approaching A from the right side of A, and it's approaching positive infinity. It is moving upwards as it gets closer and closer to the asymptote. So for horizontal asymptotes, we call those B, just for notation purposes. We could have, again, positive or negative y values. So B could either be positive or negative. I'm sketching it as if it is a positive B. So this dotted horizontal line is y equals B. And these occur when you have leading coefficients that give you either positive or negative values based on the degree of the leading terms. When a function y equals f of x approaches plus or minus b, as x approaches plus or minus infinity, then there exists a horizontal asymptote at y equals b. We can say the function hugs the horizontal asymptote to either positive or negative infinity. So we can say y approaches b as x approaches positive infinity. And this would look something like this. So x is approaching positive infinity, and the function f of x or y is approaching this horizontal asymptote. You could also write this y approaches b as f of x approaches b, as x approaches infinity. And the last one, we could say as y approaches b, or f of x approaches b, as x approaches negative infinity. Now notice that in this scenario, we are moving to the left, not the right. And sometimes you will cross your horizontal asymptote before you approach it. So it would look something like that. So we are always looking at the tendency of the function to approach a horizontal or vertical asymptote. So we want to look at the kind of like the end behavior. These will become very helpful as we move into graphing rational functions, and it may seem kind of irrelevant now, but here in the next few videos I think you'll see how it's applicable.